Imagine that you have AI Minecraft, but you can create anything. And the worlds that you can create are actually like any type of diversity of worlds like Roblox. So it's all UGC. And you can create them in a joyful way with tools as if you had like tiny glades. For me, it's all about meaningful work with meaningful people. So long as I'm doing that, I can do this for many, many years. There is no shortcut to learning. You just have to put in the work and have the mentality that you can, right? That you're able to, that no one else is better than you. If someone else did it, if I did it, you can do it too.
So let's dive into Nilo. Tell me a little bit about the idea, the core concept.
So Nilo was born out of the idea that um, so playing games is a lot of fun, but creating games can be incredibly frustrating. Like I've been creating game engines and games for more than 20 years, right? And all of these tools are so complex. Unreal Engine, even Unity, like even Roblox Studio, Blender. Like if I'm a programmer and I need to create some art, then I need to go learn Blender and push some vertices together and UV unwrapping. And it's like, that's not what I want to do. I want to code and make a game. But if I'm an artist, the same thing happens. Now I need to learn like Visual Studio and I need to learn how to code and some programming language. And then after I learn of these tools, I need to learn another tool like Unreal Engine or Unity that is incredibly complex also. So it can be very frustrating and it can require many people coordinating everything, right? And so, but playing games is just, hey, this is a lot of fun, right? And I'm like, why can't it be that way? Why can't I develop games in a joyful, very fun, very fast feedback loop way? And that's the core insight behind Nilo is that now with browsers being mature and generative AI appearing, we can actually do that. And so now with generative AI, you don't need an engineering degree or an art degree. So you can create games because genAI creates the 3D models, creates the code, creates the animation, which enabled me and my team with our experience creating game engines to create a 3D sandbox where creation is play. And it's a social environment as well. And so it becomes like digital Lego where you say, oh, I would like a car. And then a car appears. I would like the car to move. And then it does. And someone else creates a wall and then the car smashes through the wall. Or someone says, I want to play with Hello Kitty. And that happens. Then you're like, oh, then I want a pony. And now you're playing together, right? And it becomes a lot of fun. And it removes a lot of the frustration because the frustration comes from you not being able to express your creativity and imagination. You having to do things that are a little bit more menial in order to get to the end result. So what if we could get to the end result faster? So that's the core idea and insight.
Okay, nice, nice. So do I get this right? Nilo is a sort of environment where uh, you could draw the parallel from like a game engine, but with commands that I can utter using genAI. So ideally natural language, and things happen and they work.
So Nilo is actually best thought of as a game initially. Imagine that you have AI Minecraft, but you can create anything. And the worlds that you can create are actually like any type of diversity of worlds like Roblox. So it's all UGC. And you can create them in a joyful way with tools as if you had like tiny glade, or with natural language. And so if you imagine yourself in this multiplayer social environment that feels like a game where actually you have access to all of the tool set of a game engine behind it, and you can access it joyfully. And you can run it in the browser, so from multiple platforms together. Now that's what Nilo is.
Okay. Okay. So how does it work on the lower level, on your end when you're creating it? Maybe how does the interface look like for a user? And then how
Mhm.
does this map into the tech behind it?
Yeah, that's a good question. So for a user, they basically see a 3D sandbox. It's like, oh, here's a world, and that you may come into it from a world that we've created or users have created. Could be a driving game, could be a platformer, right? You can create anything. Or you could have like a blank page. And what the user sees then is just an interface that where you can say, I would like to create a cube, or I would like to create a character or a 3D model, or I would like to paint some grass. Like you have very simple tools that you just use with your mouse or with your finger if you're on a mobile phone. And then you can either type or speak commands. So the commands work in the context of specific entities. You can't just prompt to game. You can't just say, oh, I would like helicopters that shoot and blah, blah, blah. No, I would say, I would like an helicopter. I would like many. I would like this helicopter to fly, right? And so this is a very big philosophical difference between prompt to game worlds like Rosebud or Beat Magic or WebSim, where actually you're creating things, but the AI needs to guess your intention. And then you're like, oh, that's something like what I wanted, but not really. So let me continue to prompt until I get what I wanted. Whereas Nilo is more of a, hey, I already know what you want to do. You want to create a game. And I'm going to be very opinionated. I'm going to use AI for it to specifically create 3D models. And then the commands that you're going to execute in this model to create code are going to be in the context of that model specifically. And so now, instead of AI having to guess what you want to do, actually, it already has context and it knows. So it not only is much faster, it's also less error prone, right? Um, and so that's what the user does. And for us on the lower level to be able to create this, well, we have to create basically a full game engine and a full game to allow you to do this. So we've had to create a graphics, a physics engine. Basically, the performance stuff is all in WebAssembly, running in the browser, but with good performance. So, for example, we're using the Jolt physics engine, which was used in Horizon Zero Dawn, compiled to WebAssembly, running in the browser. So created our own graphics engine. We're writing our own web transport based networking system. We wrote our own animation. So, for example, parsing UFBX and animations. So we're using the micro FBX library that Godot also uses, but we've converted it to WebAssembly and we're using it. So you can just drag and drop animations and models and mix some more animations, and all of that just works in the browser very easily. Whereas normally that would not be possible. We integrate then AI into all of these systems, into this game engine and game environment. So I'm able to integrate and create the partnerships with some of the 3D providers like Meshi and Triple, but we can use any provider like Rodin, Trellis. So we're able to create 3D models using those providers, and then we can generate code using, for example, Anthropic, Claude. Like we can generate the code, but also integrate animations. So we can use Mixamo animations. We can use text to motion with our partners, Utana. So you can say, so here's what the user is able to do. I would like I mentioned, Hello Kitty. It appears in like 10 seconds. Then you can rig Hello Kitty. So you give it bones, right? And that happens in like 15 seconds. And then you can say, I would like Hello Kitty Plamol, or I want it to dance Zomba, because you can create that animation in another 15 seconds. So you're basically going from what was in your imagination to actually seeing it happen and playing with it in less than a minute. And that's something that is, I don't think you were able to do that in any other platform. So that's very exciting.
Nice. And it all happens in the browser. You have this prepared. In what language do you do this?
So it's basically TypeScript mainly for the UI, but then we have a lot of things that are written in C++ and then converted to WebAssembly. So it's a mix of WebAssembly and TypeScript.
Okay. Can we do a bit of a segue and can you tell me a little bit about how WebAssembly what is the state of WebAssembly for the browsers? Do you need to specially unlock it through the settings or stuff like that, or is it already there by default? Like where I'm not up to date on the WebAssembly part.
Now, WebAssembly is actually quite mature by now, and there are whole standards bodies, Byte Alliance, like they're stewarding the whole technology really well. And so we already have a lot of tooling around it that actually allows you to compile to WebAssembly easily from C++, from Rust, from any other kind of language. And there are now development efforts towards making sure that like interface types so that you can do an intermixing of languages through WebAssembly, right? So something that was created in C++ that generated WebAssembly can now speak with something else that was generated from Rust into WebAssembly. So that's not in yet, but this is where people would like to go. But the normal use of WebAssembly and the performance side of things, it's already running on all major browsers and runs on mobile phones, and that's all really good, and we can count on it. Now, in terms of really deep performance, in terms of threading, in terms of SIMD, and so there are some caveats there. So yes, it works, but then we had things like Spectre that made it so that you couldn't access memory array buffers directly. So then we had a lot of things on top to make sure that now you could safely, so that decreased performance. So those things are accessible through flags, and the programmers need to jump through hoops to actually access them. Like you need cross validation, you need to enable things so that you can actually use threads in WebAssembly, and it's more difficult to do, but it's possible. So the state is actually really good, unlike WebGPU, where we're still heading there. I think it's still at 72% adoption because it's still not enabled in Safari for WebGPU. So in Nilo, we're making sure that we can do things with WebGL so that it runs on mobile phones across all devices. But then we're able to change to WebGPU with one line of code. But we can't actually take advantage of all the features because we're not going to release it just now until adoption is closer to 100%. And that's probably going to take a few years.
Okay. Just to make it perfectly clear for everybody who is not maybe used to these technologies, WebGL is the web version of OpenGL, the older graphics API, right? And then WebGPU is like a Vulkan or DirectX 12 to the OpenGL. So it's like a new modern version of graphics API, allowing you to do much more and control GPU more directly, but it has issues with the support, at least in Safari. Okay.
You can think of it that way. Yeah.
It's a good enough mental model.
Absolutely, it is.
Okay. And then WebAssembly is something separate, because when you are writing your own programming language in your own programming language, like C++, and this will be converted into assembly-like instructions that will be then fed into the browser, and the browser will know how to handle it.
Exactly. So
Okay.
WebGL, WebGPU, think of it as graphics. WebAssembly, think of it as CPU, like GPU, CPU. And whereas the browser normally just interprets JavaScript and it needs like a whole virtual machine to interpret command by command, instead of doing that all the time, if you have something that requires performance, you compile it or create WebAssembly that uses a stack machine instead of using an interpreter that is just runs much faster. But that's CPU side. If you want high performance on the graphics side, then yes, you would go towards WebGL, WebGPU, and WebGPU is a higher performance version of WebGL in a very simplified hand-waving way of saying it.
All right. Awesome. So how does this work in Nilo? How do you constrain LLM to do only what you want to do? And how, generally speaking, you structured this project?
It's an interesting question. Like I mentioned, with Nilo, you're actually doing things in context, right? And how that works is that we have an entity component system, or at least we're working towards having that. And so what happens is that you actually run things in the context of the entities themselves. So instead of thinking like, hey, I'm going to prompt this and it's going to generate this whole world for me, no, you've actually placed objects. Nilo helped you place things in the world, and then you're going to issue commands to them. So you'd already know what you're talking about because that update loop, how it actually works is there's a virtual machine I've created running in the browser that is secure in its own sandbox, so that when you say something or you type something, the code is generated on the fly through an LLM and then runs inside that virtual machine in the context of those entities. And so now you're saying something like, oh, you create a plane. And then you say, I want this plane to fly. Now that code is going to be injected inside of this entity update loop and is going to make the plane fly, like in very fast feedback. And so what that allows the user to do is, so unlike other tools, like I mentioned, where you're like, I want this to happen. And then it takes you like a minute to generate the code. It needs to go and do all of the things, reticulate splines, whatever. And then you're like, oh, something appeared, but it's not exactly what I wanted. And now you need another minute to iterate on it. With Nilo, you're actually building the game with your own hands. You're actually doing things and you're playing around and playing with the characters while you're doing this. And then there's incredibly fast feedback loops for you to say, I would like it to do something, or I would like it to animate because it's in context. The AI does not need to guess or create things from scratch, right? What this gives rise to is, for example, when the browser appeared and you could see pages, you can just right click view source, right? And then you see the whole code in the web browser, right? That gave rise to millions of web developers because the feedback loop was so fast between you seeing the code of the page that you're in and you saving it and making changes. And oh, now I'm a web developer just by making little changes, right? So that's exactly what I'm enabling with Nilo, and making sure that as you make changes, even if you don't know programming, the feedback loop is so fast that now you can see, oh, if I change speed from 20 to 10, then this happens in the world. Okay, what if I change something else? And now I'm enabling the next generation of game developers that won't learn by using tools that look like Photoshop. Actually, you're just playing a game, and the next generation comes out of all this.
Okay. Okay. How then do you make sure that if you say, even if you have this
We
context and have a plane and you say, okay, now I want the plane to fly, that the code will make sense and
Mm.
you actually do what you want to do? How do you have some sort of evaluations or stuff like that?
Yeah, so that's a challenge that we are facing with because that's something that, LLMs are probabilistic, they're not deterministic. So, of course, they're going to do things that probably didn't expect. Maybe you wanted the plane to fly slower than it actually did, but AI generated speed as like 10 instead of 5, right? There's not that much that we can do about this. What we can do is to map the AI to our API so that it does things that are possible in the world. What we can do is layer on UI on top of Nilo that shows you what is possible to do, what you can do so that you don't guess. And once you actually do things, layer on UI that allows you to change it, right? So to guides you towards what you would like to do. But it's still a challenge. Things that where we would like to go towards is instead of having a master prompt that says you can do anything, actually, it's more like an orchestrator model where if you want to do something with physics or you want to do something with movement, is actually more like, hey, this is the system that deals with movement, and it has a prompt for that. So when you create a big prompt that says, I would like this plane to fly and then do this and do that. Actually, that fans out into multiple other instructions. And those instructions will have their own evaluations that say, hey, out of 100 tests that we do, 99% of the time, 99 tests actually execute this instruction and produce this kind of code. And so if you're able to do that for every specific thing, then now you're able to have more confidence that if a bigger prompt that orchestrates these ones, if these ones are working, you can put them together and have a higher confidence that something is going to work rather than have guesswork. This is where we would like to go, and I think this is a more sound approach than just spray and pray and hope that AI does things correctly.
Okay. All right, awesome. What is then the difficult parts right now of the development? Where do you spend your most time in? Is it like performance? Is it more making sure that LLM understood what you wanted to do? Or
Mm.
where are the tricky parts here?
Tricky parts are actually with AI research, because, for example, right now we have an integration with text to motion, right? And text to motion is in such an early state that sometimes it doesn't do what you would like it to do, right? So how do you get, like you say, I would like uh, I would like this character to do a push-up, and then it takes some time, and then it crawls and maybe jumps with the arms, and then it moves up again. It is not really a push-up, and you're like, okay, how do I guide the model to actually give a result that is more according to what the user would like? And you can say the same thing about anything that touches AI. Like, what is this 3D model? Can I do like image to 3D? Can I do text to 3D? Does it look like what the user would like? Rigging. The results from rigging, are they good? Do we need to develop tools that allow the user to place the bones, or do we just do one shot so that the rigging looks good from the beginning, and then layering animations on top of that, also generated with AI? Like, there's a balance between fun and control. Like the things that Nilo produces today would not be acceptable for a game developer. They would just go like, that quality is not good enough. But because our initial target audience is kids, they look at things that are not really great and they go like, this is fun. And and that's why we're starting there. Like the bar for quality is much lower. But the quality is continuously increasing due to scaling laws. So even if I changed nothing in Nilo today, Nilo would just continuously get better because the underlying models keep getting better. Um, so some of the time is spent making sure that we have the really nice UI and tools that guide AI towards something that is fun for the user and playful first. There's a lot of effort being placed into delightful UI and also fast feedback loops. So, for example, I'm not using the latest 3D models, even though they're higher quality, because I want the fastest models. I want play to be the most important thing, like time to play, right? And so we spent a lot of time making sure that performance is great. Like if you create a model or you drag and drop a model, then I want that to be almost instant, right? I don't want that delay. I want the playful feel, right? And so we spent a lot of time, and that's why we rewrote this UFBX parser. Like we wrote our own animation retargeting, like all of those things. We put them in web workers so that you didn't see any delay in the UI. Like we spent a lot of time making sure that all those interactions are as good as an actual game, right? And so that takes a lot of time because doing this the normal way, I could have just used an off-the-shelf physics engine instead of integrating a C++ physics engine. That takes a lot of time. We could have just used TCP, but we're not. We're using UDP. We're writing our own network protocol on top of web transport, right? So that you don't have out-of-line blocking with TCP, right? So there's a lot of things with relating to making something feel delightful and good that comes with polish in a game that we've had to spend a lot of effort doing.
Okay, nice. How do you like the environment, the browser environment compared to your past experience working in like either console and like we'll get to that, but like how do you like the new environment for this like low level game tech
Huh.
as a browser?
It's a very interesting question. So here are the good things. The good things is that really fast hot reloading, really fast iteration is actually possible now. Whereas before, when we were working on consoles and on desktop, we had to integrate external tools, which are brilliant, like Live++, for example. Stefan Reinalter created it. Been integrating it for in every project that I've been in. But like it's kind of painful and it's external, right? So to have that fast feedback loop in C++, it's really hard and it breaks easily, and the tools are not conducive to do so. Whereas in the browser, I make a change and I see the change immediately. Like that's super fast for me as a developer, and that's also why I enable for users. Fast feedback loops is one of the most important things. And especially now with the advent of generative AI, we actually have LLMs that there's so much TypeScript and JavaScript code out there. LLMs actually understand it. And so when I was working with Rust, I'm like, oh, do this simple thing. And generative AI is like, nah, barfs at the code. It's not simple at all because it's Rust. It doesn't understand it. There's not enough samples in the wild. But working with TypeScript in the browser, it's super fast feedback loops using tools like Cursor, where you can just vibe code your way into things. The other day, I created a particle system in a couple of hours and gave it to all the artists where they could just place things around in the world, and it's like super fast. Before AI, like 2 hours was just me figuring out why the particle systems don't appear on the screen. So like it's just a really nice environment for that. And what we lose is, for example, Visual Studio, not Visual Studio Code. The real Visual Studio has the best debugger ever created. Like one of the reasons why I don't use Max, I don't use anything else, is because the debugger in Visual Studio is amazing. You can't use it anywhere else. And so once you understand debugger-driven development, you start to develop in a completely different way, right? And it's so much faster. And you can't have that if you're using Visual Studio Code or if you don't have those kinds of tools, right? And the first time that I've switched my kind of development in more than 10 years from debugger-driven development to something else was actually now. with generative AI, because now tools like Cursor and Windsurf, now you do AI-driven development. And that's actually a 10x productivity boost over debugger-driven development. And most programmers that are not game developers, that don't know Visual Studio and the debugger in Visual Studio, they don't even know debugger-driven development. So you have like 100x productivity improvement if you stack the 10x's that could have happened. So you lose a lot of things in terms of where is your memory layout, data-oriented design. Like you can still think that way, you can still structure things that way, but you can't really pierce to the deeper levels. There's still a virtual machine running there. So you give up some things and you gain others.
Okay. That's so cool. Also, Ryan Fleury, who is working on like the debugger, Epic Debugger, was on the show. If you were to tell him like Visual Studio has the best debugger, I don't want to be in the same room that you do. But maybe he will not know. Okay.
No, I actually used the Red debugger back in the day because I was also at Epic at the same time that he was there, and I used the tool, and it's amazing. I really like the way that is approaching it, the UI that is using. So the way that is actually thinking from first principles, like I think that's great. And I think that the pace that is developing this, he will be able to create something that is even better than the Visual Studio debugger. I have no doubt about that.
All right. So what is the Nilo state right now? Where you're at and where you're headed? What's on the roadmap?
Mm. So where we're at is we have a product that is in early access where it feels like a game, right? And so you're able to create, you can do those things that I said, create a car, create walls, create grass, create any character, rig it, animate it, play around with it. I even had a user that was a 12-year-old that was very used to his Roblox character. And he's like, I want to play with my Roblox character here. I'm like, you can. He exported the model, imported this character into Nilo, rigged it, and then said add player controls. And I was running with his Roblox character inside of Nilo. And it was like, oh my God. And the multiplayer is already working. So you can see other characters roaming around. So you can create worlds together. Like we have text to motion, so you can make the animations work. So all of that is already there. And we plan on doing onboarding and monetization. And then we plan on launching in a few months. So onboarding basically is the UI revealing itself to you. So if you're given a link to Nilo and it's a driving game or a platformer game, how do you know to drive the car? Or how do you know to control the character? So those things need to be there. Like it's not a tutorial, but it's like if you hover over something or you click on something, how do you know what controls should you be given and what you can do with this object, right? So we call that the onboarding. And then of course monetization, because we're in the age of AI and AI costs money, right? So you can't just release a product and hey, use it as much as possible. Actually, can go bankrupt using all the credits. So to build a sustainable business, we need to also have some kind of monetization. And yeah, that's where we're at. We have the beginnings of we have the team, we have the product, we have some users, and now we're going to develop with the users this latest feature so that we can launch and build with the users continuously.
Okay. What do you see in the future Nilo becoming? Like, do you see at some point Nilo taking over Unreal Engine as like a go-to platform for like high fidelity games? Or is it always going to be in like this kind of more prototype oriented game / tool / game engine?
This is one of the things I love about the games industry is unlike other industries, new technologies layer on top of each other in terms of the economic model. So if you think about the music industry or video, right? You had the cassettes, then you had the MP3 player, and then you had like digital or VHS and then DVD and then Blu-ray, then digital. Each one that appeared cannibalized the previous one, right? But in games, that's not true. You had the arcades, you still have arcades, and then you had the consoles, and then you had handheld, and then you had mobile phone, and then you have VR, and then you have digital. Like all of this just keeps stacking on top of each other. It's not like one cannibalizes the other. And this is how games becomes the biggest media industry, more than cinema and music and books combined, right? And so when you ask me, hey, do you see Nilo taking over all the things? I'm like, no, I actually think there's a lot of collaboration and a lot of economic potential for all. And I don't see Unreal being displaced from AAA games anytime soon for many, many years to come. And they will even expand towards multiple other industries. And I think that's great. I think that Nilo has a lot of potential in other areas and other industries. And then, of course, it will grow from there as well. So, for example, if I now target Nilo towards 10 to 14 years old that would like to express their creativity and create their own games, there is no other platform that allows them to do that in a joyful manner, right? Where they feel like they're inside the game and creating games with their friends. If Nilo allows them to do that, that's a completely different audience from a real engine. And it does not have to have that quality level because they're not used to that quality level. They're playing Roblox and Minecraft, right? And so eventually, Nilo's quality will increase. Yes. But will it replace Unreal anytime soon? I think that would be unlikely. Um, I think where your question also was, where would you like Nilo to go in the future, right? And for me, that is also a bigger vision, right? And for me, the bigger vision is psychologically, humans, I think it's human nature for us to connect with the people that we admire and respect, right? So I don't follow tennis that much, but I do follow Carlos Alcaraz or Rafael Nadal, or you see this with books, right? You follow specific authors, or we see this also in YouTube, like Mr. Beast, Casey Neistat, or even Instagram influencers. Like you follow specific people, right? But in games, this does not happen, right? You don't see people attaching to a specific person. Like it's very rare. It does not happen at the scale that it happens to other industries. And you start asking, okay, why is that? Where is the Mr. Beast of games, right? And so I think the answer is because games are so hard to make and they cost so much money that what happens is you have studios putting out games and they take many people and it costs a lot of money. And every 3 years you have a new game put on the platform, right? It's very hard for you to connect to a studio, right? And there's not that many of them in the first place. So what happens if I create something like Nilo that allows anyone to create those types of games? I'm now enabling the long tail of creators so that anyone can create any type of game. And if I create the infrastructure and the platform to connect creators with users, now they start developing relationships. Now you're like, hey, what if I change this here? And they're like, yeah, that's great. What if you do this? And you start developing games from users with creators. And you start to have something that is a little bit like a Twitch or a YouTube, right? Because now the
Oh,
long tail of creators is now developing with users. And now you start to have something like the Mr. Beast of games.
okay. Nice. Nice. Very interesting. I also think that if you have this tool and you can now having like being 10 years old and you can now create a game when you get to like 18 years old, you have so many more years of experience designing games. It allows you to do so much more and kickstart your career, but even like creativity much earlier. Like I always think about it like if it wasn't for Unity, probably games like Outer Wilds or Obra Dinn wouldn't happen. Like I love Outer Wilds, like top best game. But imagine that if you only had if you could need to create it like your entire game engine from scratch and learn about physics and do everything yourself, this probably wouldn't have happened. And this is so cool that if you lower this like eight years more even, you get to have people that are like, oh, as children, oh, I figured this game design kind of thing. I like that, like it goes snappy like this, or if you have like it's faster this way. It's so cool to lower the barrier and then enable much more creativity. That's so nice.
That's exactly right. And the more interviews I do with the 12-year-olds, the more I realize that I'm creating the tool I wish I had when I was 12.
All right. Where can people follow the work? How can people stay in touch? What do you recommend people do if they want to follow the Nilo development?
Yeah, of course. So Nilo.io is the main website. So nilo.io. So there's a Discord button at the top right. Feel free to join our Discord or put your email address to join the early access. Also on Twitter or X at Nilo Tech Inc. and on LinkedIn at Nilo-Technologies. We should probably at some point consolidate this into one. Uh, but if you want to also follow me, it's my Dane and a P and my last name. So NUNOPLEIRIA on all the socials. Feel free to DM me. My socials are open. I think the things that we didn't mention in Nilo are the incredible team that we built. And like, for example, Ron Millard, he worked on Diablo, Warcraft, Starcraft. He was 8 years at VR Chat. Like he's amazing, creating all of the little worlds that we have in Nilo and making sure the product goes in the right direction. Silka, she was at Adobe, so she has a lot, 20 years experience leading design. Like we have so many people with web, VFX experience creating this that it's the thing that makes Nilo shine is the team is actually incredible at building this. So I just wanted to shout out to the team. They're amazing. And yeah, that's it.
How big is the team now?
We're now 9 people.
Okay, nice. That must be so cool to have like 9 experienced people working hand in hand. It's so cool. All
It's the
right.
best feeling. For me, it's
Okay.
all about meaningful work with meaningful people. So long as I'm doing that, I can do this for many, many years.
Awesome. Look, you have done a project in the past that feels like a high tech from the future,
Mm.
and I wanted to ask you about it. Uh, you probably know what I'm talking about. Uh, in your time at Polystream,
Mm.
you were working on a project where you had like a streaming based solution for games. Maybe you should do the overview of the project to make it more cohesive. Can you tell me about this project?
Yeah, of course. So Polystream was a Silicon Valley style startup, but based in Guildford in the UK. Guildford is actually a big games hub where Lionhead was, Media Molecule, like many game developer studios there. And Polystream was a startup that was created by Bruce Grove, who, by the way, is now an advisor in Nilo today, and Adam Billiard, who is the creator of Renderware back in the day before he was acquired by Electronic Arts. It was the big game engine where GTA actually started, and before Unreal Engine and Unity commoditized the whole thing. So Polystream was created to do cloud gaming, but without using video, right? And the way that it worked technically was actually that you virtualized the graphics card in the cloud, and then you compressed and sent the graphics commands to the client and rendered them on the client. Now, this was 10 years ago. And the point why we're doing this is because Bruce and Adam, they realized that there's not that many GPUs in the cloud, and the ones that exist are super expensive. So the ways of doing this before was like OnLive and Gaikai, that became PlayStation Now. Like these are very, very expensive things. And actually, what people don't understand is that the technology was there and it works. And you can see the technology works with Stadia, for example. But the problem is actually the business model, because if you have all of those GPUs, now it takes a lot of money to pool all of those servers and all of those GPUs. Like electricity is actually a big cost. And so how do you keep buying all of those servers and all of those GPUs? And then what is the monetization model for users? Like that was a big problem and why all of these systems kept failing. So Bruce and Adam came together and created this system where actually now you don't need GPUs in the cloud. Like you basically lie to the game and you inject like on the Windows DLL level, you say, hey, I want to use DirectX. And we are saying, yes, you're using DirectX, but basically rewrote the whole of the graphics driver API so that the game would run on bare bones CPUs from GCP, AWS, or Azure, So you have a lot more availability because there are not that many availability of GPUs at the time. So we could use a lot more of the CPUs all around the world, and we could run the games that didn't have a graphics card attached to them. And we created this whole stack where the game says, I want to draw, I want to run this shader. And we're like, yes, basically compress the commands, send them over the wire, and then display them correctly to the user. So without any video artifacts. So what we got from the client was the user input mouse keyboard, send it to the server, render the frame on the logic on the CPU. Then the game would say, I want to render this frame. It would grab all of those graphics commands, compress them, send it to the server at like 16 frames per second. And we would do this all the time for AAA games.
How is this possible to do this on the CPU and then also adapt? How is this possible? If what had to be done in the first place to enable it?
Oh man, how much time do we have?
This is like so futuristic concept to me that it's wild. And it was 10 years ago.
Yes. So the way that it actually works is that we had a proxy for DLLs. So basically every time on Windows, right? When a game wants to start, they go to DLLs, right? Like Win32, kernel32 DLL to get all of the functions from the APIs. So when a game wants to render, they ask for D3D9 DLL or D3D11 DLL, right? So what we do is we put a DLL in there that we wrote and say, hey, game, instead of using System32 D3D9 DLL, you're going to use ours. And the way that Windows looks for DLLs is actually first it looks on the folder of the game. Then it goes and looks, then it goes in System32, right? You know that there's a procedure to do this. So we took advantage of that knowledge. We rewrote a completely new D3D9, D3D11 DLL. We had to rewrite parts of Win32. We had to rewrite parts of Windows itself to lie to the game. So when the game says, hey, what size is my monitor? What system am I running on? Do you have these graphics capabilities? We would basically lie to it and tell the game what it wanted to hear. And at some point, we were actually sending the information from the clients to the server. So the client, like it's running maybe on a cheap Intel integrated graphics card. The client says, I have these capabilities. And we would pass to the server and tell the game, hey, these are some of the capabilities of this client, but actually it's running on an NVIDIA. It's running on something, right? And so we had to rewrite the whole of the stack for graphics and some for Windows so that we would be able to do this. Like when the game says, I want to create a vertex buffer, we would write a shadow memory buffer, right? So that we would hold the differences between the current state of the game and what the game would like to write. Because then we had to use those differences to compress the data and send it. One of the biggest challenges was actually memory bandwidth. So we used a lot of techniques from the compression world in order to make the data transfer very small. We had to use delta, XOR, quantization, shuffling, zigzagging, like so many, and compression like Z standard, for example. Like we used Z standard, we used Z standard in raw dictionary mode to do streaming compression, which so how do you do deltas? You have a frame, right? And then you want to compress that frame in comparison to another because you're doing so many frames per second, right? But they're similar. If they're similar, you can compress one with respect to the other and have a much smaller size, right? So what are the tools that actually allow you to do this are, for example, tools like BSDiff that take two memory data, compares them to another, and then says, okay, what are the differences? And then makes it smaller, okay? And then on the other side, you unpack that and get back the result. It turns out that BSDiff is a great algorithm, but it's mostly for offline use cases. So it uses a lot of memory, like it's not that fast. Like, okay, how do we do this memory comparison and compress the data, but for real-time use cases? So through a lot of trial and error, I realized that actually Z standard, which is something like zlib, but much better using asymmetric numeral systems, and it's much better, much faster compression and decompression. That can actually work as a much better comparison compressor that is not just for you to compress a file. It can actually be used in real time if you use it in this mode called raw content dictionary mode. And what that does is you're compressing this piece of memory using this other piece of memory as dictionary, right? And that works exactly the same way that BSDiff does, where it actually is taking two pieces of memory, comparing them, and then compressing them because they're so similar. Well, that standard can be used in the same mode. And once I figured this out, now I'm like, oh, we're just going to use that standard and use it as a compressor and decompressor on the fly on every frame. And the best thing about it is that you can even change the compression levels on the fly. So I developed something that analyzed the performance of the game in real time. If the performance was getting slower, then compression would also lower the level so that it would increase the bandwidth but take less performance. Or if I saw that there is more performance in that frame, then I could increase the level and decrease the bandwidth. So all of that was
Nice.
happening in real time, right? There's a lot of technology like this.
Nice. This is so high tech. This is incredible. What happened to the project then? Like how did the project work out in terms of like business or like a product
Mm.
standpoint?
Yeah, so we had a few partnerships with, like, for example, Tomb Raider. We had a close partnership with them in order to stream Tomb Raider. We had quite a few projects that we were working on internally, and we even got 12 million Series A round from Intel. So we were in close partnership with Intel as well. And also World of Tanks developer, like we were in close partnership with them to integrate our Polystream technology with their launcher, right? Nilo couldn't be used on a B2C level, so direct to consumer. Like it didn't make sense. Like why would people use it?
Nilo, Nilo or
Sorry,
Polystream?
Polystream. Polystream couldn't be used direct to consumer because most people get their games from
Yes.
stores like Steam, like good old games, right? And so that's why Polystream was being sold more towards businesses, right? And so that reduces the number of businesses that you can sell to, right? So it needs to be integrated in something like Steam or Good Old Games or a developer that actually has their own store, right? Like World of Tanks. And so that made it more difficult to actually sell. And eventually, what happened was that after 4 years, we couldn't actually have a sustainable business model, and the company was acquired by Mythical Games. So it was one of the best technology stacks that most people have not heard of.
Nice. This is so cool. Can I ask you, you when you're telling this story, it shows that you're thinking out of the box and you know this technology like to the bone. Where have you learned that, and what would be your advice to people that would like to be in this state when they have first
Hmm.
the knowledge and they also like this ability to kind of like hack things together to
Hmm.
make something 10 days ago impossible now possible?
Hmm. That's an interesting question. Um, Look, there is no substitute for actually doing the work. Like even when I was at Polystream, I was waking up at 4 a.m. studying compression so that 3 hours later I could go to work and apply those compression techniques. I didn't know compression before I got to Polystream. And then I figured out, hey, that standard is actually good. And now we can use it in this way. Like that's trial and error. That's me studying programming. So like I had this massive book on data compression next to me because I kept studying. And like there is no shortcut to learning. So I've been making games since I was 12. I've been teaching myself games programming, did a master's in games programming. I did computer science and engineering. Like every single day, I'm studying the games industry. And now I have my own company, and now I'm studying business, right? And how do you how do you get investment, and all of that stuff. So you just have to put in the work and have the mentality that you can, right? That you're able to. That no one else is better than you. If someone else did it, if I did it, you can do it too. Like, so you just have to put in the work and study and actually apply yourself. And yeah, I would say that's one of the most important things.
Is waking up at 4 a.m. necessary to the process?
Like I said, there is no shortcuts to doing the work. Like, I don't think it's necessary, but someone else that is doing that is gonna get that faster.
How much daily do you work? How much time?
So now that I have Nilo and it's my company, I'm working all the time, like
Okay.
16-hour days, normal.
Okay. Oh, how was this before? In the days before, like in Lionhead or Piranha Bytes.
Okay, so when I was at Piranha Bytes, that was my first job in the industry. At that moment, like I was working, like I wanted to be a game developer for so long at that moment that was basically me getting my dream. Oh my God, I played Gothic when I was a kid, and now I'm working at Piranha Bytes. It's like a new country, new everything. So I was working extremely hard because I enjoyed it so much, not because anyone told me to. Um, and then at Lionhead, I was now working. I had played Fable when I was a kid. So now I'm playing, I'm creating Fable Legends. Again, it's the same thing, is that joyous feeling of, oh, I'm doing something that I always wanted to do. So again, I'm working hard. And it's a new engine. So 4 years at Piranha Bytes, I was working on the Genome engine, custom engine, like rewrote the whole PlayStation 4 thing, Xbox 360, worked on all the parts of the engine. And now at Lionhead, it's Unreal Engine 4. Now I'm like, oh my God, millions of lines of code that I've never seen in my life. What do I do here? So I had to work hard to figure it out, right? Same thing at Polystream. Like, I don't know compression. And now I need to learn all of this stuff. Now I need to write a D3D11 driver layer, like all the time, because it's new and because the field is advancing. I'm always working hard because I actually like it. And so this is the thing that Naval Ravikant says. He's an entrepreneur and he's a philosopher also. He says, I find the thing that looks like work to others, but is fun to you. What is the thing that is so much fun to you that looks like work to others? Just do that. And then it's not work.
Okay. Okay. Where are your sources of motivation? What are these?
Hmm. It's a great question. My inspiration comes from a lot of places, and it differs from project to project. So right now, I'm getting a lot of inspiration from the 12-year-olds I'm doing user studies with, and a lot of inspiration from seeing them enjoy Nilo, and that fuels me to continuously make Nilo better. Like interacting with the team, like working with such an incredible team, is like seeing something new that, hey, now we have animation on web workers, and it's like, oh my God, this is amazing. And that fuels my inspiration for the next things that we can do with that. Um, but when I was starting, my inspiration came from seeing like the emotional resonance that games had within me. Like I was playing Final Fantasy VII, and that was the game where I was like, oh my God, what I'm feeling right now is what I would like other people to feel. So that fueled me. It's like Westworld. If you've seen that series, they have the cornerstone memory, right? So for me, that became my cornerstone memory that then developed everything else. And so what fuels me now is different from what fueled me back then. But it's very important to keep finding that renewal source of inspiration wherever it may be. And I find a lot of inspiration in books. I read voraciously all the time, and books are such an incredible joy of just for information, but also from stories of other people and how they've done it. I study with from a lot of entrepreneurs and other people in the games industry, like the history of John Carmack and Tim Sweeney, and these are people that built the industry itself and are still with us and working. Like this is amazing. So those are big sources of inspiration to me too.
Okay. Are there any book recommendations from you?
Oof, so many. On what? I need like specific guidelines because it's
Well,
just so vast.
maybe on the game industry, game programming kind of
Mm.
niche. Do you have something that you'd like to recommend to
So
the
Game Engine
listeners?
Architecture by Jason Gregory is one of the top ones. I remember when I was younger reading Code Complete. That was also interesting for me to form my thoughts around what good code looks like. Uh, there's so many books like outside of games, just on structured thinking. For example, Clear Thinking by Shane Parrish is also really good. Uh, and yeah, I could go on, and this is yeah. So for example, Nassim Taleb, anti-fragile, nothing to do with anything, but like just the mental model, just the idea of anti-fragility is like you know that things are fragile, like a vase, a glass of water. You throw it to the floor, it breaks, right? It's very fragile. Something that happens externally will break it, right? What is the opposite of that? We have no word for that. Like, what is the thing that gains from disorder? If something external attacks it, how does it get stronger? Like your muscles. You work your muscles, they get stronger, right? If you apply pressure. Nassim Taleb came up with that concept of anti-fragility and how you can apply it to all things, to investments, the barbell strategy, like how do you make your life more anti-fragile, right? So there's the book like this size, right? So that kind of stuff that has nothing to do with game programming actually helps my game programming career, right? So
Yeah.
that's just an example.
Yeah. Nice. Okay. Can you tell me, a lot of people are now a bit worried, concerned about the state of programming,
Mhm.
and some of that has to do with Gen AI, but a lot of it seems to be like with sort of lowering standards for some aspects. What is your take on this as a person that is like very deep into the making very cool quality stuff? What are your thoughts about on this?
Look, I'm a perennial optimist. I always see the bright side on things, and it's not like I don't know or ignore the problems that appear. Like I'm a very big proponent of mechanical sympathy. Like I want the machine to sync to like the. It hurts me when you see things like the global interpreter lock in Python. You're like, what are you doing? It doesn't need to be this way. Like I want things to be data oriented. I want the cache to be, in a very flow state without load hit stalls, no cache misses. Like I like that. Mechanical sympathy is very important. And yet, I also want programmer productivity. I also want to have this joyful feeling of developing. And right now, I get a lot of joy on getting things done from using AI, for example, and vibe coding and saying, hey, I want you to do this. And then it actually develops the code. I'm almost not coding, but because I have so much experience, I can guide AI towards it. Like AI is not, I don't think of AI as like input token in, input token out. I think of it as like a program search space. And you have programs inside of the LLMs that you can get into, right? And so your queries, as you put inputs into it, are actually trying to guide it towards that program that you can take out, right? If you know what you want, if you already have experience, then you can guide it much quicker, like a homing missile towards extracting that program. If you don't, you're just guessing, right? So AI today, I think, raises the floor and raises the ceiling, which is very exciting. If you don't know programming with just some natural language inputs, now you can start to learn programming because you can ask it, what's the API? What's the documentation? How do I do this, right? Someone that knows nothing gets to know something very quickly. Don't need to read books or Windows API internals and all of that stuff that I had to do. But it also, but it also raises the ceiling. Me, with my experience, I know exactly what I want to do, but I can do it much quicker. AI can just write that code and I can do that homing missile thing towards the program in a much faster way because I know exactly what that thing is, right? So it's much faster for me. And I think that's a very exciting time, even though it brings a lot of concerns towards, hey, what's the code quality of the thing that it's actually outputting? How do you make sure that the quality is good? Aren't you producing an army of low skilled programmers that don't know and don't have that mechanical sympathy, right? And yes, that's a challenge. But I don't think the solution is to restrict that. I think the solution is actually, hey, empower that and then give even more information. allow things like handmade hero to appear. And then the people that have the curiosity after they learn programming and they do the vibe coding thing, create code that is not really performing well and is running at 5 FPS, their natural curiosity is going to go, why is it running at 5 FPS? How can I make this faster? Oh, now I'm learning about game engine architecture. Now I'm learning about, how mechanical sympathy and cache coherency. And if you allow that natural curiosity to shine and give people the resources to actually learn about it, I think that's much better way of going about it than saying you're doing it wrong, you don't know what you're doing, stop doing that. Like, okay, yeah, what is the person going to do, right? Maybe you move to woodworking or something because the culture is not conducive for them to learn.
This is such a cool view, like optimistic and positive about it. I love it. I rarely hear that optimism in the genAI predictions.
Look,
This
I'm
is so
building a
cool.
whole tool around genAI, so of course I'm going to be optimistic.
Yeah. And yeah, and also like I think that engineering and programming or animation and things like that you can learn. You can put in hours and GenAI can help you with that if you ask, hey, can you tell me? Maybe it will hinder you in a couple of places when you say like, can you do this for me? Like, not
Mm.
worry about it. But I love that with your tool that you're building with Nilo, you can actually help people iterate faster on the game design aspects,
And,
which is like trial and error for me, eternity. Like
and
I can get my head around programming, but when I try to design something that is fun, it's just so difficult.
Mm.
It's just so difficult. And then if you can enable it so fast, such an early age, sorry to come back to the same point that I've made like earlier, but this is so cool. I love it. And the positive aspect of GenAI, the vision that, hey, you can help this easily create stuff that you never have was possible before, and you can learn from it, and then you can apply the more rigorous training. This is really nice. I love it. I like it a
Thank you.
lot.
I appreciate the perspective. And, I think that's very true. Like, in other domains, we have some kind of ideas or formulas of what great looks like. So, for example, in movies, like the top 10 movies, almost all of them follow a format, which is the hero's journey for storytelling. Like, we know this, right? And so you can form a certain structure around how do you tell a good stories in movies, or how do you structure a good comedy series show? Like each episode will have the same format. Once you know it, you can't unsee it. But with games, what is fun? How do you get to fun? It's exactly like you said. You need trial and error. You need to figure out what that mechanic loop is like. That is actually the core of the game. That is a lot of fun. And how do you figure that out? Maybe one day we'll have a theory of fun that actually works and delivers great games. But we don't have that yet, as far as I know. And so you need to trial and error. And the only way to do this is to have extremely fast feedback loops that actually get to that core fun. And that's what I'm trying to enable as well.
Awesome. What do you like more, the business side of things, running the company, or the like programming side of things and
Ah,
engineering?
no one has ever asked me that. That's a great question. Um, I think it has transitioned over time. I was always enamored with programming and building game engines and enabling technology, and that's always been some of my core. Even until I arrived at Epic, and now I'm working on UE5 and Fortnite, and it's like this is amazing. But at some point in scale, once you arrive at the scale of Fortnite, you're like, I make one character change, 15 minutes waiting. For 10 platforms, you're like, oh my God, it becomes kind of frustrating, right? Even though what you're doing is super cool, man, it's frustrating. And so as I developed myself and the skills that I can do, it became a lot of fun to exercise a bigger breadth of skills than just programming. Like, oh, how do I raise money? And how do I build a team? And how do I manage the team? And how do I structure a project? What about the vision? Lawyers and all of that stuff. And for someone like me that really loves personal growth, development, and doing different things, that became a really great source of inspiration that I can exercise all of those skills and continuously learn. And that came with programming also because, if you're in programming games, and especially on the consoles, like the PlayStation 3 comes out, you're like, oh, I have to learn about SPUs and PPUs and all of that. But then the PlayStation 4 comes out, you're like, okay, throw everything out the window, learn everything again. And every generation is different. So that is a really great source of learning. But eventually, even that is like, okay, what's the next thing? What's the new thing? And right now, for me, that's business. That's building a team, building a product, getting users. There's it's difficult to find a higher expression of providing value for others than actually creating something that people want. And their neutral expression of this provides value for me is giving their money, their hard money to you, right? And so if that's possible, then you know that you're creating something that is of value, hopefully. And so now that's becoming more and more my focus, and I'm letting more and more the team do the actual coding.
Awesome. I love the enthusiasm and positivity. That's so cool. That's so refreshing. After spending some time on the internet, it's so refreshing. I really hope that Nilo will take off soon. How is it? How how is it to work with 12-year-olds in terms of like how is to gather their opinions?
Mm.
How much if you have an adult, you can assume that this adult has some sort of serious opinion. How much does it change when you're dealing with 12-year-olds?
Oh man, 12-year-olds are so opinionated. Like you can't fake that. If something sucks, they will tell you. Like, but if something is fun, they will tell you too. You can't fake that kind of joy. When you see them, their eyes lit up, you're like, oh, so this is something that you actually want and care about. So it's very refreshing. And when you're an adult, you bring some baggage with you. Like I have it, everyone has it, and you have an idea of how things work or how they should work. Like I was mentioning, that quality is like, oh, you have an idea of how animations should look. So if they look different from what you expect, it's wrong. Whereas if you're a 12-year-old and you haven't seen these things for a long time, you're like, oh my God, that's so funny. I didn't expect it to do that, right? And if you pair like physics with animations generated by AI, now you have something that is like, oh my God, what is this, right? And it's very, very refreshing to have that opinion, to see those reactions, right? So I have to say it's harder because they also don't have the experience to tell you what they want, but they're also very honest in saying what they enjoy versus what they don't. So then it comes to me and the team to figure out where to go from there and how to guide them towards what fun and joy looks like. Whereas a game developer would go and say, yeah, you need to do X, Y, and Z, and these are the problems. So it's much easier, right?
Okay, okay, awesome. Nuno, thank you so much for joining me. This was such a lovely discussion.
Absolutely. It was a pleasure. Thank you so much.